I prepared a little talk to show you a few examples of games. At the same time, we do in Portugal lots of promotion of abstract games among the students, not only chess. And lots of what I heard here today applies equally well to abstract games, not only chess. Chess is a great game, it's a fantastic game, we all know that. But chess is an abstract game, and there are others that also deserve attention in a pedagogical, didactical point of view, in my opinion. So let me start with this little game from Egypt 4,000 or 5,000 years ago. This game is the game of Senet. It's not the oldest game that we know of, but well, it showed up in the tomb of Tutankhamun, and we know pretty well the rules, more or less. It's a race game, maybe one of the ancestors of backgammon, and you see the pieces and the astragals that play like dice. They actually use a lot of binary dice as well. But here you see Nefertari's tomb, and you see her playing Senet. And apparently she's playing against a wall. Everybody knows that the only games we play against the wall are video games or puzzles or something. This is a two-person game, so there's something else going on. And what's going on is that she's playing against the god of the after-death world, Osiris, and she's deciding in a game whether her ba, it's that thingy there, the bird with her face, it's something like the soul, we would say today, if it lives after death or not. So this game was extremely important for the Egyptians a long time ago, and I just bring this here to show that games are no light matter. Games are really serious business. Here, this is another tomb of a couple that died, and the husband is playing his game of chess, and you see the souls, the bars of the couple on the right, so we presume the game went well and they lived happily ever after. Now I'm going to show you a game that maybe, I hope you never heard of. It's a pedagogical game, a game created for the classroom in the 11th century to teach mathematics. So the rules of this game show up in ancient manuals for the teachers, where you teach arithmetic, where you teach the quadrivium, you teach rhythmometry. And this game, we have in Portugal one manual of it. There was an English famous writer also, I think from Cambridge, William Folk, that also wrote a manual. This is from the 16th century, and it's this that I follow mostly. This is the board and the pieces. As the manuals say, you take two chessboards, put them together, and then you are ready to play this game. Chess didn't have light and dark squares by then. So this is a numerical game. You see the front row. Do I have a pointer? Well, even numbers, the front row of black pieces with odd numbers. I'm going to jump very fast to the rule according to which you build this initial position, because it's a little bit tricky, and I'll show you here. I'll breakly on the right column how this is done. So there are lots of proportions and relations in these numbers, and why is that so? Because we are using this game to teach mathematics according to the tradition of the Middle Ages. So the tradition is not Euclidean, it's the tradition of Pythagoras. You teach whole numbers, classification of numbers, simple ratios of numbers, classifications, proportions, and means. The arithmetical mean, geometrical mean, harmonic mean, mostly, and the simple shapes, the simplest shapes, circles, triangles, and squares. So, we have two solid pieces. It doesn't matter much, but it's an imitation of chess. They wanted to have something like the king, so they have two pyramids that are actually sums of squares, and these are the pieces of the game. Because it is a pedagogical game, you are supposed to learn the rules that depend on the shape of the pieces. So you have, I don't see this there, you have the piece, this is, you build the initial position. You are supposed to place the players on the longer sides of the board, because the manuals say that you should look and let sink in yourself all this harmony that the numbers show. I just say this because we have to try to understand what was going on 1,000 years ago. People were studying this kind of mathematics before studying theology in churches and monasteries. Universities didn't exist by then. Then this game, because it was very fancy, this game was also taught in universities, in Oxford, in Paris, and so on. And it survived for a long time. Actually, it was the most popular game among educated people in Europe for 500 years, which is amazing. It was not chess. I hope I bring you news. You thought it was chess, it was not. So the rounds, because they have only one side, they only move one square. The triangles move 2 squares. They don't move up to 2 squares. Diagonally, exactly 2 squares, no jumping of the other pieces. The square moves orthogonally and diagonally. Then those kings, these move like chess queens. There are some special rules for the kings that I'll jump. And then come the captures that are nice, because now it's not geometry, now it is numbers that we have to deal with. You know, this game was played with little stones, painted stones, 2 faces for each piece, a black and a white, with same number, because in this game, like in Japanese chess, when you capture a piece, you can reintroduce it in the game in your favor. And now, suppose you have 2 pieces with same number, and it's white to move. If you remember, the triangle could move diagonally 2 squares. So if it moves to the center of that diagram, it would be attacking the black piece. And that's exactly what happens, only that in this game, at that precise moment, the black piece is taken away. So from this position, we go directly to this position. It's a rule that is not very common, so it's a little bit difficult to visualize, mainly because the board is very large and one move can give rise to several captures. So this is the same number capture, because the pieces, as you saw, they have the same number, 25, capturing 25. The addition, I'm going to give an example how 2 white pieces that show a 9 and a 16 can capture a 25. The white piece is already threatening the black piece, so we just need to move the white triangle diagonally up to the right and get to this position. In the moment it gets there, the black piece disappears. You know, this game was played with Roman numerals and sometimes even with Greek letters, alpha, beta, gamma, to represent the numbers. So this was not that easy as it is for us, because the numerals were not so easy to handle. The subtraction is about the same. We have a white 15 already attacking the black 9, so if we move forwards 1 square, the white disk, we get 15 minus 6 equals 9, and the black piece disappears. So from this position, we go to this position. The multiplication and division operate on the values on the attacker, the defender, and the number of squares between. So the situation is like this. Suppose it's black to move. Black is moving a piece with a 12. The victim has the number 4. So what happens is that the triangle moves to the left, to the bottom left corner, leaving 3 pieces between them, and so we calculate 12 divided by 3 equal 4. And so we capture that 4. And of course, multiplication is the inverse operation, so if it's white to move, 1 square orthogonally down, and 4 times 3 is 12, and black piece is captured. In the manuals of this game, because there are lots of captures that go unnoticed, they introduce that rule that the kids use today when they play checkers. If a player doesn't see a capture, they steal the piece from the board. This rule is very common, so I don't even put the numbers. It's just by taking all the possibility of moving from the black triangle, so you just capture it by a setting. There are special rules to capture the kings. I'm going over that, jumping over that. And then, how do you win at this game? The manuals show smaller victories are what we understand is given for the students to practice. Like if you see, I don't know, Wayne Rooney scoring penalties or corner kicks during the week. It's not a real thing, it's just practice. And so we practice capture pieces, or in chess, first one to give a check wins, things like that. But then comes the good stuff, which is this one. That is based in progressions. You know, there are mainly 3 progressions that are very common. You know, it's the averages, the mean of the two numbers. You add numbers, divide by 2. So you have 3 numbers in arithmetic progression. You have the geometric mean. If you multiply and take the square root, it's the geometric progression. And there's a trickier one, is the harmonic progression. It's harder to say in words what it is, but given 2 numbers, it is the 3rd number that solves a very nice problem that I'm going to show. If you go from here and you drive 100 miles at 60 miles an hour and come back immediately after at 40 miles an hour, what was your average speed? Don't say 50, please, but it's wrong. It's 48, and this number 48 is related to 40 and 60 by this harmonic thinking. Well, this is extracted from a book of arithmetic that was used in the Middle Ages in Europe, from Boasius, and it shows a nice way of spotting the progressions. I show it because it's really nicer than we usually learn how to do it. This is a nicer way, and it's better for game practice. For instance, the grand victory, you have to put 3 pieces on the other half of the board showing a progression. Like the first one is 2, 15, 28 is 2 plus 13 is 15 plus 13 is 28. Or the second one is a geometric progression. You multiply by 1.5 is 9, and you get 50. The largest minus the medium, divided by the medium minus the smaller one, and hope to get the largest over the smallest. Okay, 9, 15, 45, it's one of those triple numbers that gives the victory. But then there is still a fancier way of winning, is the major victory. You have with 4 numbers to make 2 progressions. Let's just see the first one. 2, 3, 4, 8. 2, 3, 4 is clearly an easy arithmetic progression. 2, 4, 8 is a geometric progression, ratio 2. And of course you can guess that's a Maxima way of doing this. In 4 numbers, do the 3 progressions, which is really for masters. And it's really a difficult game. And if you try to build a progression, usually it's easy to spot what you are doing, and so your opponent will try to kill one of your pieces and so on. It's tricky. The most beautiful piece of history related with this game is the way it dies out. This game was never spoken against. It was always considered to be the best game ever. Some books say it was Pythagoras himself that invented it. Here in England it was called the philosopher's game. It was a fantastic game, and somehow it disappeared. There are no traces of this game. We have to go and dig deep in the books to find it. And why was that? Well, it was for two reasons. One, mathematics change. The creation of calculus, infinitesimal calculus and algebra, this game didn't adapt. It adapted all the way through until the 16th century, but then it couldn't adapt. So the game was taken out of the classroom. And the game, as you can probably guess, because I bored you too much, the game is not good as a game. I mean, it doesn't survive as a game. So nobody plays it, so nobody wrote anything, but it just died out. And from that moment on, chess really took over, and it's today the most popular game ever, I think, if you count the Asian variants and so on. Now let me show you another example on the other end of this spectrum. This is from my exhibition. I have an exhibition of old games in the Lisbon Science Museum. And this is my board. I'm very proud of this board. It's very beautiful. It's a Monarchia board. So you are invited when you go to Lisbon. You just let me know. I'll show you. Just a little note. In Utopia, those people that only do good things, they don't play silly games, but they play Monarchia, which is very interesting. And they play another game that is there written in green, that nobody knows which game it is or it was. And somehow I think I found out which game it was. That's another story. Next year I'll tell you about. And I think this is the board of that game. And those 12 levels are 12 virtues with 2 vices on the extremes. And I'll show you later that. Okay. Now I would like to show you another example of game that is the game like the goose game. The history is long. Even in Egypt they have this kind of game that is just a path. You throw a die and you move on, and whoever reaches the end wins. This is a big mystery still. We don't know if this is a game or not. It's 4,000 years old. It's very beautiful. This game of goose was actually invented on purpose as a gift from Francesco de' Medici to the King of Portugal. Actually, the King of Spain, but you were part of Spain by then. And it was invented, and there are sources, historical sources, so we know that it was invented. And somehow it was made one game to give to a king, and I think you all know how to play this game. You throw a die, you move your thingy, and whoever finishes first wins. The game became very popular. This is in Gioco dell'Oca, it's Italian. There are thematic instances of this game. This is a kind of romantic, Cupid version from 17th century France, and many others. But the interesting thing about this game is that the main rules, that are only a few, they were preserved. This game is still being, you can buy this game still today all over the world, essentially with the same rules. In this game, the player does nothing, throw a die, actually 2 dice, nothing. Okay, so apparently this game has no virtues at all, ludic virtues. However, it's still being published, essentially with the same rules, with these rules that I summarize here. This is the version I use in my classes. I have a course in the University of Lisbon in history of board games, very popular, and I teach also this game. I made the experiment of putting the kids playing this game in large numbers to see if the game has some virtues. It does have some virtues. For instance, you see that, let me show you, the 58, if you land on 58, you go back to square one. You know that the main thing about the rules is if if you land on a goose, you repeat your throw. So the dice show 5 and you land on a goose, you move 5 more. So this is the rule. If you see the board, the typical board is this. If you at first take a 9 beginning the game, because the geese are on the 9th square and then every other 9, you would finish the game. So you have to prevent that. So you go to 26 if you take 6-3 in first throw, and you go to 53 if you take 4-5 in first row. All the games show this, all. In every country around here where this is produced yet. Now imagine that you are in 58 and you get a 9 when you are on 58. According to the rules, you would have to count until 63, 1, 2, 3, 4. In this game, if you hit 63 and you still have a count to do, you do it backwards. So you would go backwards again to 58, and you would have to repeat the 9, 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 and you will be out. So this rule that they invented of putting going to the first square if you get a 58 was very well thought out. So whoever invented this game, he knew what he was doing. This is on one hand. But on another hand, there's another thing that is, I don't know how to jump all this that I showed already. I'm sorry. I would like to show first, next. The thing is that whoever invented this game, invented it with ludic virtues, but the numbers were chosen in a very particular way. These numbers were no accident. The 63, the 7, the 9. This was the Kabbalistic interpretation of the world that was popular, that was cutting-edge philosophical knowledge by then. So even a game like this, that is so low in our scale of abstract games, so low, even a game like this shows the cultural and historical relevance that surprises every day. And for some reason, and that is mysterious to me, the game is still popular. Like I have here, this is modern day Scotland. The rules are the same. It doesn't look the same, the spiral is not here, you just see a giant goose, but all the rules are the same. 63, the same accidents. If you look for 58, you'll see a hanging goose. So you can understand this is the games world is fascinating, and I'm not talking about the deep culture of games like was started by Huizinga in the 38th of last century, and that started a fascinating field of. Okay. And so I will let you with this image of Rugal with kids playing, kids and adults playing from the 16th century, and I thank you very much for your attention.
Okay, so open up. We'll have a couple of questions before coffee break. So to either David or George. I see one from Jennifer Shahadi.
Yeah, I was just wondering what you were about to say about Huizinga, the field you were about to talk about.
Well, Huizinga started a field of studies, of cultural studies of play and games. That is absolutely fantastic, and we cannot avoid it. We are chess and abstract games and mathematics lovers, but we cannot ignore it. It's a fascinating world. That theory and culture of play, it's fascinating. This book is a fantastic book. And the first sentence in the book is that one. Play is older than culture. And from here on, after this moment, the difference between play and real life, it's made very clear, and now we have to think deeply about what is play, what is art, what is justice, what is religion, what is love, what is this and that. The differences between play and all the parts of our lives that deserve study and reflection.
Okay, one more question here.
Go ahead.
Actually, two questions. First, I would like some information on the Nefertiti picture, because this is this picture is sent to me approximately once every 5 years to prove that chess was invented in Egypt.
Yeah.
And it's clearly not chess.
No, it's Senate.
Yeah.
It's Senate, but it's easy to see that it's Senate because Senate gave rise also to hieroglyph. There's a hieroglyph with the sound mn that is a Senate board. So it's very well known. It's a 3 by 10 rectangle with 10 pieces on top, alternating. It's very well known.